Hey guys, welcome back. So we are going to move on to lesson 2.2. So I'm going to present my screen and we'll get started. Okay. So for lesson 2.2, we're going to continue to talk about different types of statements and reasoning. We're getting prepped to get into our proofs. That's where we're headed. Okay, we do have some vocabulary that we have to go through. So a conjecture. Okay, and I'll write this out. Let me find my pen. Oh, ignore that line. Actually, I can erase that. Okay, so a conjecture is an unproven statement that is based on observations. Okay. Next, we have inductive reasoning. Inductive reasoning is a process that includes looking for patterns and making conjectures. So you guys have used inductive reasoning. We're going to use it today. When you were younger in elementary school, middle school, when you'd see a pattern and tell the next term or the next shape or the next whatever that would come in the pattern, you were using inductive reasoning. You were looking at a pattern and then making a conclusion based on your observation. All right, a counterexample. A specific, and this is an important word, the specific part, a specific case for which a conjecture is false. I was about to write F, is false. Let me erase that. Oop. I was trying to clean it up and I made more of a mess, is false. All right, deductive reasoning, and this is what we use a lot in geometry class, a process that uses facts, definitions, accepted properties, and laws of logic to form a logical argument. To form a logical hide this. Logical argument. Okay, so we're going to be using deductive reasoning once we get into our proofs. Okay, and that's where we're headed. All right, so that is the vocabulary. Let me move on. All right, laws of logic. So we have two different laws we're going to talk about today. One is called the law of detachment and the other is called the law of syllogism. Okay, so law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. I'll read that again. If the hypothesis of a true conditional statement is true, then the conclusion is also true. All right. The law of syllogism. All right. This says if the hypothesis P, then if hypothesis P, excuse me, then conclusion Q. If hypothesis Q, then conclusion R. If both of those statements are true, then you can take the hypothesis of the first statement, the conclusion of the second statement, and write a true if-then statement. If hypothesis P, then hypothesis Q. Sounds a little confusing, but it actually is not once you see the examples, okay? So I'm going to go back up to law of detachment and do an example, then we'll come down to law of syllogism and do an example, okay? So let's see. All right, so for law of detachment, I'm going to say if two segments have the same length, then they are congruent. All right, and then I'm going to say, you know BC is equal to XY. And I'm going to ask you, what can you conclude? All right, so first off, determine whether or not the conditional is true or false. If two segments have the same length, then they are congruent. That is a true statement, right? Because that's the definition of congruent segments, right? Two segments that have the same length are congruent. So then I want you to identify the hypothesis and the conclusion. The hypothesis, two segments have the same length, and the conclusion, they are congruent. So the additional statement that's given, if it agrees with, if it deals with, if it matches with the hypothesis, then you'll be able to make a conclusion. So it says, you know that BC is equal to XY. Okay, BC is equal to XY. Does that have anything to do with this first statement? Two segments have the same length. Isn't that what this statement here is telling you, that these two segments have the same length? So if you know that these two segments have the same length, then what conclusion are you allowed to make based on the if-then statement? You're allowed to conclude that the two segments are congruent. So you can say, you can then conclude that segment BC is congruent to segment XY. Okay. Now, this additional statement that's given, that little extra piece of information that's given, it always has to match with, pair with, deal with the conclusion, or excuse me, the hypothesis, couldn't come up with the word. It always has to deal with the hypothesis in order for you to use the law of detachment and make a conclusion. So that's something to pay attention to. And we'll look at different examples later on. All right. Okay, let's go down to the law of syllogism so you can see how that one is used. All right, I'm going to try to squeeze it in the space here. All right, so I'm going to give you two if-then statements. Okay, so the first says, if you get an A on your math test, then you can go to the movies. All right, if you get an A on your math test, then you can go to the movies. The next if-then statement is going to say, if you go to the movies, then you can watch your favorite actor. I don't know if you guys can hear the background noise in my house, but if you can, I apologize. My 6-year-old son and his cousin don't know how to be quiet. Okay. So again, if you get an A on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. And my question to you is, what conclusion can you make? What conclusion can you make? Now, the law of syllogism says, and by the way, we're going to assume that these are true if-then statements. They have nothing to do with definitions, but we're just going to assume they're true. The law of detachment says if P, right, you get an A on your math test, then Q, you can go to the movies. And then if Q, so notice how the conclusion of this statement is the hypothesis of the next, you go to the movies, right? Then R, then you can watch your favorite actor. And I would underline this 3 times. Okay, so what conclusion can you make? Well, based on the law of syllogism, you're allowed to say, if you get an A on your math test, then you can watch your favorite actor, right? So if you get an A on your math test, then you can watch your favorite actor. All right. So it's almost like the parts that repeat, almost they don't cancel out, but that's kind of sometimes students like to say they kind of overlap, they cancel out, and then you can take the beginning of one and the end of the other. But that does have to happen. The end of one, the conclusion of one must be the hypothesis of the other in order to use the law of syllogism. Also keep in mind with the law of syllogism, our conclusion was written in if-then form. Law of detachment, it was not an if-then statement. You just said a sentence. You didn't have to use the law, or you didn't have to use if-then form. All right. So that is it for this lesson. Yep, that's it for this lesson. So let me just delete this and I'll say goodbye. Go here, go here. All right, guys. So we'll meet back here for the next lesson, 2.3. Bye.